Welcome back. Today we're going to be adding and subtracting, or rather adding fractions in this lesson and subtracting in the next one. So remember that a rational expression is really just a fraction with a variable like x, in the numerator or the denominator. So since we'll be adding these complex rational expressions, we'll want to talk quickly about the basics first. So before we jump in, these are the problems we'll be doing from today's lesson: 1b, 2b, 3a, and 4b. Now let's get started. So let's focus on the left side first, and then we'll see how that connects, how each example connects with an example that you'll see in this lesson and how we deal with it. So in our first example, we have 1/3 plus 2/3. So immediately, our denominators are already the same. So what we can do then is combine our numerators, and we're just going to add straight across, keeping the same fraction. So I really went 1 plus 2 all over 3. And that's 1/3 plus 2/3 gives me 3/3, which is 1. Okay, now that's similar to here on the right when we already have denominators that are the same. Again, we'll do the same process, just combine the numerators. That's going to be 1 plus 4x all over that common denominator, 2x minus 1. And that's all that there is to it. Second example. This time we have denominators that are different. However, we can get common denominators by changing the left. Out of 1/3 and 1/6, our common denominator would be 6. And in order to get this 1/3 in terms of sixths, so that we have a common denominator, we're going to need to multiply it by magic 1, 2 on top, 2 on the bottom. That gives us 2/6 plus 1/6. So now that I have those common denominators, we can add straight across, and I get 3/6. Now, here's what's interesting about this problem. A lot of times we do problems like this very quickly without thinking too much about what's happening. So I'm going to break it down slightly. I'm going to rewrite the 1/6 as 1 over 2 times 3. So 2 times 3 is the same as 6, right? So have a look at our denominators. From 1/3 to 1 over 2 times 3, we have this 3 as a common factor. Okay, they both have the 3's in common. So I'm definitely going to have something involving a 3 in my common denominator. But this guy has an extra too. So what we're doing is we're basically letting the guy with less catch up through multiplication. So our common denominator takes what they have in common, which is the 3, but then also takes into account the leftover. And so hence we got the 2 times 3, or 6, as our common denominator, and we just had to make that left guy catch up. Let's look on the right so we see an example of how this could happen in our homework. So over here on the right, I've got nearly common denominators, but not quite. They do have the x minus 3 in common. Now that common guy is like the 3's over here, is what they had in common. So you'll always copy that down. So we've got taken care of this and this. But notice we have this leftover factor, x plus 1. Well, if one guy has it, everyone needs to have it. So it's part of my common denominator. And now I just need to figure out how to make both fractions line up with this common denominator. In order to do that, I'm going to have to work on the left side, multiplying it top and bottom by the missing factor. So the way I'll solve this problem then, just like how we did over here on the left, we multiplied the 2 times 1, which is 2, and then added the 1. So we got 2 plus 1, or 3. In this case, we have to be a little more careful. I have to multiply the 4 times x plus 1 using distribution. So it's going to be 4x plus 4, and then I'll add the 2. So we end up with an answer that looks like this. Now notice that I was already in factored form here. It's not going to be like that on our homeworks. We'll have to factor it ourselves. But my purpose is to show you when you have different denominators, how you're going to find the LCD, the least common denominator. Let's do one more example. All right, now we have 1/2 and 1/3. So unlike my previous problem where I could rewrite 6 as 2 and 3, in this case, I can't rewrite 2, I can't rewrite 3, they're already in their most basic format. So to get a common denominator, I just need to multiply these guys together. They have nothing in common, so I need everyone to get the 2, I need everyone to get the 3. So my least common denominator is going to be 6. How will I get that? Well, this guy needs the missing piece. And this guy needs the missing piece. So here's what we'll do. We're going to multiply the 3 times 1. And then add the 1 times 2. Because this is really 2/6 here on the right side. If you do the multiplication. And on the left side, I'm really dealing with 3/6. So we had to get our numerators the same, our numerators adjusted. And now we can combine. 2 plus 3 is 5, and 5/6 is our answer. So here on the right side, we'll do the same process because x plus 1 and x minus 2 are completely separate factors. They don't break it down. So the only LCD that we can come up with is their product, or basically multiplying them together. Now to get the left fraction to catch up, I need to multiply it by x minus 2. To get the right fraction to catch up, I need to multiply by x plus 1. And now you'll see we have common denominators. So we're ready to add our numerators together, just having to remember that this multiplication and this multiplication involves distribution. So let's do it. I have 3x minus 6, and now I'm going to bring down the plus sign, and then 2x plus 2. We'll just combine our like terms. That's going to be 5x minus 4 all over our least common denominator. So if you need to come back and reference these, it's very helpful to remember what's our next step, how to find our least common denominator, if you're aware of how these more basic examples work. Let's jump in with a problem. So if I were to label these examples we just did, like example 1, example 2, and example 3, well then problem 1b would be most similar to example 1 that we did because we already have LCDs, least common denominators. We already have that. So we can just add straight across as we did before. We'll combine our numerators. At this stage, all I have to do is combine my like terms. So I've got x plus 4x is 5x. I've got minus 1y plus 6y, which is plus 5y, all over my common denominator of 12xy. And that's our answer. We just need to talk about excluded values. So what x cannot equal, what y cannot equal. Since all of these are being multiplied together, x cannot equal 0. Because remember, I need to make sure my denominator never equals 0. Similarly, y cannot equal 0, because if y was 0, then I would have a 0 in my entire denominator. Not allowed. Okay, so we're finished now. Let's go to example 2b. Okay, so for this problem, we need to make sure that everybody has the same stuff in their denominator. So my least common denominator has got to take into account that I need an 8, but also I'm dealing with a 2. Well, my 2 can catch up with the 8 if I multiply it top and bottom by 4. So my least common denominator is going to involve an 8. And now this x squared between x squared and x, my LCD will be x squared, because x can catch up with x squared by multiplying top and bottom by x. See, x times x gives me the x squared that I need, but I can't go smaller from an x squared. So you always want to catch up with what's more. You got to have everything that they have in common. So if that's my least common denominator is 8x squared, we need to make our left and our right rational expressions both catch up to that. So on the left, I'm multiplying top and bottom by x over x. And so this becomes the 8x squared that I need. On the right, I need to multiply the top and bottom by 4. And that 2 times 4 times x squared will give me the 8x squared that I need. So I'm going to show this as 2 steps. This is really 5x over 8x squared plus 16 over 8x squared. I just multiplied across. Well, since we have common denominators now, we can simply combine our numerators. We get 5x plus 16 over 8x squared as our final answer. Let's talk about our excluded values. X cannot equal, so observe what makes our denominator equal 0. X cannot equal 0. All right, number 3. Okay, so between examples 1, 2, and 3, let's have a look here. I have x minus 2. Don't forget to put parentheses over these plus and minuses expressions, because these guys are kind of, the plus and the minus act like glue. You can't separate the 2 from the x. You can't separate the 4 from the x. So this would be most like example 3, because our denominators have nothing in common, right? It's like over here we had the x plus 1, and we had the x minus 2. They have nothing in common, so our least common denominator is just going to involve both of them being multiplied together. So to get there, we're going to need to multiply the left expression, top and bottom, by x plus 4. And we're going to need to multiply the right expression, top and bottom, by x minus 2. So we can actually do this all in one step if we wish, and I will do that right now. They have common denominators already, so we know that we can start combining. Our least common denominator is x minus 2 times x plus 4. But before we combine our numerators, we have to perform this multiplication, and then we'll add, and then we'll do that multiplication over there for our new numerator. But we have to distribute very carefully. So we've got 3x squared plus 12x. Now I can bring down the plus sign. 2x squared minus 4x. Finally, now we can combine our numerators, our like terms. So 3x squared plus 2x squared gives me 5x squared. And then plus 12x minus 4x gives me plus 8x. All over x minus 2, x plus 4. So notice that we can actually factor our numerator. And if we can factor, we should always try to. In this case, because we want to see if we can simplify things. In this case, I can pull out an x. I'm left with 5x plus 8. But factoring out the x in this case didn't do anything for us, because nothing can cancel. That's not allowed. So in this instance, it's kind of useless to factor. It's not necessary. But keep in mind, always try to factor if you can simplify it, because sometimes it'll allow you to cross things out, and that's going to be expected as a part of your answer. If it can simplify, you should simplify it. In this case, nothing goes, so this is our final answer. All right, so before we move on, let's find our excluded values. So to do that, we set our denominator equal to 0. In this case, I get x equals 2. And in this case, I get x equals -4. So my excluded values are going to be 2 and -4. They make my denominator equal to 0, which is no good. All right, our final problem of the day is from number 4. Now this problem, as complicated as it looks, is actually like example 2. It's like example 2, but not yet. So have a look. Here's what happened. We had denominators. Yeah, we had this denominator, x minus 3, and then this one had x minus 3 and x plus 1. So it had 2 factors, and then the left fraction needed to catch up. So in this example, we're going to do the same process, but first we need to factor our denominator. Factor first, and then use that to find the least common denominator. So let's factor the left side. I'm going to use the magic x method. So in my left fraction, I need 2 numbers that multiply to -50, and then that add up to +5. Those numbers are 10 and -5, but since there was a 2 out in front, I'm going to need to divide both of these by that 2 and simplify. So 10 over 2 becomes 5. -5 over 2 does not simplify. But according to this kind of little trick with magic x, we put an x in the denominator. So I'm going to rewrite now my problem, having factored this quadratic here as b plus 5, that's from this piece, and then 2b minus 5, that's from this piece, plus b over 2b minus 5. And let's remember to put parentheses whenever we have pluses and minuses joining our terms together. So see how this problem is similar to the one I was discussing before. They both have 2b minus 5 in common, so our least common denominator will involve 2b minus 5. But we also need a b plus 5, which is like our catch-up or our leftover. So I need both of my fractions to have this denominator. That means I'm going to have to adjust this right side over here. So I'm going to multiply it by b plus 5, top and bottom, to get what I'm looking for. All right, we're ready now to combine our numerators. So write down the least common denominator first. I always find that that's helpful. So since this guy on the left isn't being multiplied by anything, we just copy him down. We get b minus 5, bring down the plus sign. But this numerator is actually b times b plus 5. So again, distribute. That's b squared plus 5b. We're now ready to combine our like terms. So I have b squared plus 5b plus 1b is plus 6b. And then we've got minus 5 all over 2b minus 5, b plus 5. Now this could be a good final answer, but it's possible that our numerator could factor and simplify. So we're going to have to check that out. We need 2 numbers that multiply to -5 and add up to 6. How about -5, -1? No, those don't multiply. Okay, wait a second. Let me do some thinking here. Multiplies to -5. Well, -5 and 1, or 5 and -1, but neither of those will add to 6. So it looks like this is not factorable, but we tried. This would be our final answer. Last step, excluded values. So we're going to set our denominators equal to 0. So you could set this denominator equal to 0 and then this one, but that would involve factoring, which we actually did on the next step right here. So if I were you, I would just set my factored denominators equal to 0. So from here I get b cannot equal -5, and from here I get b cannot equal +5/2. And now we're done. Hope that was helpful. Have a great day.